Here we are going to talk about a traditional method for key phrase extraction. So let us start with a brief overview of the history of key phraseification methods. Key phrases were initially introduced in the late 80s as a means for cataloging and indexing documents in digital libraries. And proposed methods for producing key phrases can be divided into three different categories. First, we have assignment methods that map thesaurus entries to documents. Popular examples of such methods are used in the biomedical domain to map PubMed abstracts to concepts from the medical subject heading thesaurus or the unified medical language system. Second, we have extraction methods that identify the most important words and phrases in documents. These methods became popular in the late 90s and early 2000s, with, among others, the pioneering works of Witten and colleague on the Kia model and Mielcha and Taro on the text rank model that we will see later. And third, generation methods that produce words and phrases that summarize the content of documents. And these methods rely on deep learning and differ from extraction methods in that they can produce key phrases that do not occur in source documents. And in this tutorial, we will focus on the later two categories of methods. So proposed methods can be distributed along two axes, whether they are traditional or neural-based, and extractive or generative. Traditional methods encompass methods that use statistical features to extract key phrases, graph-based ranking methods to key phrase extraction, methods that train binary classifier on manually defined features, and also methods that leverage external resources to generate key phrases. Existing neural-based methods are divided into sequence labeling methods that extract key phrases using VBIO tagging, embedding-based methods that rank key phrases using semantic similarity measures, and sequence-to-sequence methods that today arguably attract most of the attention from the NLP community. In this section, we will focus on traditional methods for key phrase extraction, and we will see the neural-based method later in the second part of this tutorial. So traditional methods for key phrase extraction are pipeline-based and involve three steps. In step one, key phrase candidates, that is word and phrases that are eligible to be key phrases, are identified within the content of the input document. In step two, key phrase candidates are ranked or classified as key phrase or not, based on a set of features. And finally, in step three, the highest ranked key phrase candidates, or those classified as key phrases with the highest confidence score, are selected as key phrases. Here we will go through each of these steps in details, starting with step one, candidate selection. So the purpose of candidate selection is to find out the potential key phrases in a document. We know that manually assigned key phrases are mostly noun phrases, and that they rarely exceed 3 words. To illustrate that, this table shows the 5 most frequent part-of-speech patterns found in the author-provided keywords in the KP20K dataset. What we see is that more than half of the gold key phrases are unigrams and bigrams, and that they match the simple noun phrase patterns noun, 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 and adjective noun. So what we want here is to devise a method for identifying the textual units from an input document that have the same properties. Key phrase candidate selection often requires some level of text preprocessing, the bare minimum being tokenization, but preprocessing operations such as sentence splitting, part-of-speech tagging, NP chunking, or name entity recognition may be necessary. The two commonly used candidate selection methods are n-gram selection with some filtering, in this example removing candidates containing stop words, and non-phrase selection, NP selection. Here is a text sample with the corresponding key phrase candidates identified by these two methods. Of course, n-gram selection produces a larger number of candidates, but it is more robust to noisy text and can be applied to all languages. The choice of the candidate selection method is really important because it determines the size of the search space, that is the number of candidates to rank or classify, as well as the upper bound performance of the model, that is the maximum recall related to the goal key phrases. Ideally, what we want is the smallest number of candidates with the highest possible recall. And additionally, filtering techniques can be applied to remove bad candidates that comes from noisy documents. For example, commonly used datasets such as Senival 2010 contain full-text scientific articles that were automatically converted from PDF format to plain text. And as a result, these documents contain many irrelevant pieces of text, for example, muddled sentences, table, equations, footnotes, that require special handling so as to not hinder the performance of models. A 2-point increase in F measure was observed when key phrase extraction models are applied on cleaner texts. So once key phrase candidates are identified, the next step is candidate ranking. The purpose of candidate ranking is to assign a score to each candidate according to how important it is for the document. There are two approaches for ranking candidates: unsupervised methods that use a weighting function to compute a score for each candidate, and supervised methods that cast key phrase ranking as a binary classification task and compute a confidence score for each candidate as being a key phrase or not. The first family of methods for candidate ranking contains unsupervised statistical methods. These methods use a variety of features for scoring candidates, including frequency-based features, such as TF-IDF, mutual information, or statistical language model, position-based features, such as candidate offset positions, and lexical and syntactic-based features, such as part-of-speech tags and casing. Commonly used statistical methods are TF-IDF, which are still used as a baseline in recent works, language modeling from Tomokiyo and Hurst, that uses a KL divergence to compute and unify phraseness and informativeness scores to rank candidates, and the YEK that combines multiple statistical features to compute candidate scores. Another family of unsupervised methods that has perhaps received the most attention from the community is graph-based ranking methods. Graph-based methods for key phrase extraction were introduced in the seminal work of TextRank by Mialche and Taro, and involve two steps. First, a graph representation of a document is constructed in which nodes are the lexical units we want to rank, that is word or phrases, and edges represent the semantic relations between them. These relations can be as simple as the number of co-occurrences within a fixed window of words, or more semantically grounded, such as the distance between the phrase embeddings. Then, nodes are ranked using a graph theoretic measure, most often derived from the PageRank algorithm, such as here in this slide, the TextRank algorithm. And the top-ranked nodes are used to form key phrases. Many graph-based ranking methods for key phrase extraction were proposed, and what we show here is only a very brief overview. So methods were proposed to improve the node ranking function, such as kcore, that uses the graph degeneracy approach, or position rank that includes position information in a biased PageRank algorithm. Another line of research focuses on topical information to improve the diversity of the extracted key phrases, such as topic rank that uses a clustering approach to group candidates into topics, and topical PageRank that biases the ranking function towards distribution inferred by a latent Dirichlet allocation. There are also methods that leverage external resources, such as expand rank, that incorporates information from similar documents to enrich the graph representation, and cite text rank, that incorporates information from citation contexts. Supervised methods can also be applied to rank candidates. One way to do it is to train a classifier to differentiate between key phrases and non-key phrases. The best known method is KEA from Witten and Collie, that uses a naive-based classifier trained on two statistical features, which are TF-IDF and the first appearance position of the candidate. More sophisticated methods were also proposed, for example, the winged news system that participated in the Semi-Eval 2010 competition, and that uses a large set of manually defined features, including automatically detected section information and font weight and style information. But because they use traditional machine learning algorithms with a small number of parameters, these methods require only a few training samples to train and significantly outperform unsupervised methods on datasets where a few training data is available. And once key phrase candidates are ranked, the last step would be to select a subset of them as key phrases. A straightforward approach to do so is to select the n highest scored candidates as key phrases, and being a parameter to determine according to the application needs. However, redundancy within the selected key phrases should be taken care of so as to improve the diversity of the set of extracted key phrases. This is particularly important for methods that rank candidates according to their component words, because they are prone to overgeneration errors. One simple strategy to address this issue is to filter out candidates that are included in other higher ranked candidates. So in this example, machine and learning are included into machine learning, so they can be reasonably removed to make room for other key phrases. So before wrapping up this section, let's have a quick look at how effective traditional methods are and how they compare related to neural-based generative methods. So in this table, we see the performance in terms of F measure at the top 10 key phrases and the mean average precision of several traditional methods on 9 commonly used datasets of various domains and annotation types. Overall, what we observe here is that traditional methods are clearly outperformed by neural-based methods, but they are still interesting and competitive when no training data is available. So let's conclude this section with the advantages and the disadvantages of traditional methods. So on the pros side, these methods are quite efficient and can be used to process large batches of documents, even long documents. Their output is interpretable and they can be easily adapted to fit the task at hand. They can be applied on documents in most languages and achieve fair performance on most datasets. On the cons side, these methods are pipeline-based, so errors are propagated through the different steps. We are limited to output present key phrases, and their overall performance is an order of magnitude lower than properly trained neural-based methods. This 3 steps framework introduced by traditional methods serves as a basis for unsupervised neural-based extractive methods, and we will come back to it in part 2.1. And recently, these methods were also used to produce synthetic data for training neural key phrase generation model, and we will see that in part 2.2 of this tutorial. So it is now time for the demo session using the Python key phrase extraction PKE toolkit. So PKE is an open source Python-based key phrase extraction tool that provides an end-to-end key phrase extraction pipeline in which each component can be easily modified or extended to develop new models. PKE is available on GitHub and can be pip installed. It requires spacing for text processing, and therefore you will need to install a model for each language you want to use. PKE provides a standardized API for extracting key phrases from a document that consists of the 5 lines in this example. The first line is to initialize the model. Here, topic rank, but many models are implemented in PKE. The second line is to load the document and to do the preprocessing using spacing. The third line is to identify key phrase candidate. The fourth is to rank those candidates. And the last one is to get the best key phrases. And each of these steps can be parameterized and modified. So we will start the demo in a minute. The link to the demo is shown there. The demo session is divided into 3 parts. An introduction to PKE, parameterization, and benchmarking model. There are collab links for each of the notebook, and I will show you that in a minute.